welcome to this new tutorial on basically how binary works and the effects it has in modern day circuitry, as well as the programming which you do every day. In this tutorial, I'll teach you how to coincide your code with making sure that it works pretty fine with whether it's 8-bit, 16-bit, 32-bit, 64-bit, or whatever the case may be, because coming up soon is 256-bit with quantum computing, and you'll be able to do some pretty epic things. That is what the whole AMD Threadripper thing is about, making sure that the CPU is compatible with the new quantum technology on a basic level. Now, to make sure your code is compatible, first you have to understand basically what the basic components are. So in binary, you're dealing with ones and zeros. So like in this console output right here, here's the string output 11010011. That's the representation of binary in a string fashion. However, that when it's sent through the circuit boards to display, say, the letter 8, for instance, all of that may display. I'm not sure what. Is it 8 base? 1. Uh, yeah, that's an invalid letter because it's basically 256. Yeah, because it proceeds with a 1, and that becomes Chinese characters rather than English characters. Only the ones where on the third digit is a 1, rather than first two beginning with a 1. So something like, for example, I believe a valid character in binary would be like, don't quote me on this though. That's one too many. There could be something like the letter Z or X. If not that, then perhaps a hash or asterisk type thing. And so yeah, that's basically one of the valid symbols or letters on a keyboard represented in binary. And they're all done with 8 digits, because in pairs of 8, and yeah. Anyways, if we're to translate this code into numbers, say we want to line 64 of these up, and then process it into a number. But say we have an old-fashioned DOS 0.0 computer that's not capable of processing numbers, but is capable of processing scripts and binary. And so we want to program it to basically just process sheer numbers. What would we do? In short, what you do is I've created a function already. You need a bus, and so basically you create a type class, and so depending on your language that you're programming it in, it's probably going to be C or even assembly. If not that, then what's the other one? It starts with the letter D, not Delphi, but the other one. I forget what it's called. Anyways, after you initialize your type class, then basically you want to initialize lists and put into a huge array your bus queue. And so you put into, like, whatever way you do this in your language, you put into an array your bus. So I believe in JavaScript, that would be like, I believe that's how you do it in JavaScript, and many other languages as well. Anyways, after that you go to the post_int_bus method, which is under the same category as type, and then you dump into it the list right into the parameters. And so we go right to the, the type. Now, at the very top here, as you can see, this implements bus. The implementables, as we can see, are basically the post_int bus and post_str bus. This is for room for expandability if you were to develop this application out, because basically it's a dummy application at the moment that doesn't do much apart from a demonstration example. However, the string section does a thorough job. It does all this stuff down here. And also in the bus we've got this right here, which basically defines them right there. And yeah, in your integer section, basically what you'll want to do is like to bridge them together as a single type of like how you call it, variable, I guess you'd call it. Basically what you need to do is most of the, like, I'll put it, it's tricky to explain. It's done by 2 to the power x, and so what you have to do is you have to communicate with the operating system, or for that matter, you have to communicate with the device drivers of the screen, and then pixel by pixel display whether it's a number 2, for example, or whether it's number 5. And then draw it on the screen. So for example, if you want to draw a number, you have to physically tell the computer to do so, rather than just doing it. And if you want to store something as an integer, that's technically impossible, because when you store something, the computer translates it to binary. That's a fundamental principle of computer science. So one way or another, you have to translate everything to binary. Whether it's when you're communicating with the microtransistors, or whether you're basically storing stuff on a hard drive platter, or storing stuff on SSD even. Next, on a string sort of things, how do they get things out of strings then? Like a string stored on a hard drive? Well, basically what this is like a, how do you call it? Excuse me. Uh, it's basically, it's basically like when you get an array of integers and you like string them together. So what they do instead of integers is they get an array of characters, which is single letters, and string them together. And in case you didn't know what the symbol is for single letters, it's char. Same for all languages. Uh, so yeah, what this does is say like that it'd be that 8. It'd be something like that. And or you could even do like say for Villa syntax. Okay. Let's see if we can move this. Okay. So yeah, that's basically just another example. Um, so this here is how strings are stored, and that is then equal to that. So this here, the char array, is essentially a translation of the string, and to prove that, Let's quickly run this again. Okay. Let's try it. How's that happening? Oh, I see, because they're running at electrical cars. So, yeah. I'll explain in a second. See, as discovered there, basically what's happening is this top one right here, STR string, is displaying the electrical car, and so it's displaying it correctly as intended. The other one, the reason why it's displaying it in binary is that it expects a binary input. Now, when you, or for that matter, in PHP, the method for this is called old, D. But obviously I'm not in PHP right now, so I can't exactly show you the side effects. And you can order different characters. Oh, I do know of one actually. What do you call the equivalent in Java is string.val. actually, one it is like card. One it is something like string dot value of bet for car. Any outputs for car? No. No. Yeah, so basically when you're inputting into those, you need to like put in something like, no, not in that. Just something like that even. And that will get you like the character Z. And with that across the board, you'll get yourself a character array. And with binary arrays like this in the character array, you end up with something like this. I'll do it in the but there don't have to be 8 across here, there just has to be 8 per thing. And let's get rid of this. What's causing the errors? And then if we run it again, then there's QWERTY AB, which is a supposable output of this here. And now, how do you get this car thing? Where does it come from anyways? Basically, in other words, it comes from like, imagine like a list, an unbuffered list. Or better yet, an array, that's an unbuffered list. So like these arrays, in some languages separated by that. And basically, they actually form the foundations of what you call buses, I suppose you'd call, like software buses. So that way you can have pairs of things rather than just one. So that being said, with these buses, you can have multipliers for things like multiplication, subtraction, addition, and so forth. And there's certain buses embedded into the microprocessor that are already available for use. But if those aren't sufficient enough, then what you can do is essentially, how I put it, you can to some degree, like, I suppose you call it, uh, even like, use the processor chip as a form of expanding the software buses by basically the processor chip has a memory cache. It has several memory caches actually. For to expand efficiency and all that, but the one that specifically you want to focus on is basically for just like what be called if it's into it'd be uh into is it mem cache? Yeah, I think it's mem cache on Intel. Mem cache on Intel is a way of rapidly boosting the performance, but it also allows for basically the CPU to communicate with the operating system on many tones and levels. And one is for the operating system to be able to essentially detect bridges in a CPU and basically, how I put it, to like, in a way, do a rough roadmap of the CPU. But the sense that this is applicable to us is that it allows the CPU to expand more sockets. When I say sockets, I mean buses. Because the number of points on a bus is generally on Intel 256. Now, what you need is virtual buses. Now, Intel generally has a limitation when it comes to virtual buses. It's somewhere around the neighborhood of 65,000, or on a really good processor, about 1 million. So, these virtual buses, what they're there for is to communicate with the operating system on a mem cache, and basically, the mem cache, which is what hogs your CPU on Windows 8.1, 8.0, and 10, and non-excusably 9. They basically just cough meltdown. Anyways, like these virtual buses, they can be used for things like floating point operations and all sorts of stuff for when dealing with low level operations. And so, yeah. And it's sort of like running multiple applications over the one internet connection line. It's impossible over copper, but or a bus, but if you have a virtual bus, then it's possible. So it's a virtualization that allows you to have multiple concurrency at the same time. Uh, so that's pretty much it. If there's any questions, just leave them in the description and I'll try to answer them. And I see there's a massive queue of questions in my comments bank, so I'll try to post more videos and answer them one by one. In case you didn't know, I was rather sick when I made this video because I had the flu. So yeah, cheers though, and have a nice time. Peace out.